So, a really interesting application of protein engineering is the production of enbrel, which is a type of drug that treats things like arthritis. And what that is basically a type of joint inflammation. So, let's say you have a joint, a really rough joint here, with two bones, and the gap between these two bones is actually not closed. There's usually fluids in here, and sometimes you get bubbles in there too, so that's how you get the popping sound when you crack your knuckles. But anyways, so inside this gap, there is a type of substance called TNF, right? And what TNF does is it basically attracts your immune cells. And TNF is good because it initiates the immune response. But when there's too much TNF, it's going to attract an excessive amount of immune cells like neutrophils and macrophages, and they're all going to come rushing in, right? You got all these little immune cells, I guess, if that's what they even look like. Maybe some tentacles, I don't know. But when these cells, when they rush in, what you get is, again, inflammation. There's way too many. I'll just represent the cells as dots. There is simply too many cells here. And that's going to cause, you know, this part to swell up. And in the short term, inflammation is just inflammation, usually an excessive amount of fluid. But if left untreated, what this does is it's going to start eating away the um, the soft plates on these joints, on these bones more specifically, which could lead to long-term negative impacts. So, and what enbrel does is it inhibits TNF. So when there's too much TNF, there won't be too many immune cells attracted. So yeah, that's basically the purpose of enbrel. And how it's made is actually quite interesting. So basically, it uses a technique called, well, not a technique, but it uses a type of DNA called recombinant DNA. And as mentioned before, usually the process of protein engineering is to use actual DNA and transcribe it into RNA so it can be produced by ribosomes to get the protein you actually want. And in order to get the DNA to produce enbrel, what researchers did is they looked at the human DNA and extracted specific pieces on it which produced antibodies that binds to TNF. So say we got these three different types of genes here, which all produce a specific protein or antibody that binds to TNF. And when they put all of these guys together, when they combine them, and when they, produce enbrel through transcription and ribosome, sorry for my messy writing, but when they do that and get enbrel, it's a protein that's really, really good at simply binding to TNF. And what that does is it basically stops it from, spreading out even further and causing, and while attracting more immune cells and causing more destruction. So yeah, it's a pretty unique drug, I would say, and serves a very important purpose.